Hi everybody, and welcome to our first video for this school year. Hope you are going to enjoy these and that this is going to be a good learning tool for you. What I wanted to start off with is just some algebra skills review for each of us. You might be a little rusty over the summer, so hopefully this will be a refresher. All stuff that you learned last year, the year before, and just stuff that we'll see this year and something for us to get started with. So the first few problems that we're going to work here, all we want to do is simplify and perform the operation that's given to us. So here we have 4x to the 7th over 16x to the 5th. So I want to simplify this fraction here, or if you want to think of it as performing the division. So what I'm going to do is look at this and look at the similar terms and simplify each of those together. So when I'm looking at the 4 and the 16 separately, and I'm just kind of going to set aside the x to the 7th and x to the 5th. So if I'm going to simplify the fraction 4 over 16, that's just going to simply be 1/4, right? Because 4 goes into 16 4 times. So I can simplify that to 1/4. Then I have x to the 7th over x to the 5th. And for that, I'm going to remember my properties of exponents. And I know when I'm dividing or when I have a fraction like this, I have x to the 7th over x to the 5th. What I'm going to do is actually subtract the exponents. So if you even want to think of that off to the side, you can write it. It's going to be x to the 7 minus 5, which is going to be x squared. Now, where that goes, I'm thinking of if this number is positive or negative. So the exponent here is positive, so that means it's going to go up in the numerator. So I have 1x squared over 4. You could also write that as x squared over 4. If you were to get a negative number, let's say this was if I had x to the 5th up in the numerator and this x to the 7th down in the denominator, and I had 5 minus 7, I had -2. Whenever I have a negative exponent, I put it in the denominator to write it with a positive exponent. So that would have been 1 over 4x squared. So the x would have been in the denominator there. So that's what would have happened if we would have had a negative exponent. So those are all properties of exponents, and we'll review those as we get to them as well. So that's the first problem. Let's look at another one, multiplying two binomials together. So in this case, we'd want to use our FOIL method. If you use that, it's where you multiply the first terms, then the outside terms, then the inside terms, and then the last terms of each binomial. So that's the FOIL method. So what we mean by that is we're going to multiply the first terms. So the first term in each binomial is x. So x times x would give us x squared. The outside terms, which is going to be right here, the x, and then on the outside of the second binomial is the 8. So that's going to be positive 8x, so plus 8x. Then I'm going to multiply the inside terms. So that's the 4 and the x. And remember that that subtraction sign, x minus 4, really makes this a -4. So that's -4x. So I'm going to say minus 4x. And then I want to look at the last terms in each binomial. So there's my -4 again and my 8. And that's going to be -32. The last thing I have to do here to simplify this is x squared plus 8x minus 4x. I'm going to combine those like terms, and that's going to be plus 4x and then minus 32. So that's just performing the FOIL or multiplication over two binomials. Some other things we'll do here is simplifying radical expressions. So the square root of 81, that should be an easy one. That's 9. Sometimes you'll see a plus or minus in the front because remember 9 squared would be 81 and -9 squared would be 81. When you don't see any signs in the front, you just assume that it's going to be that they're asking you for the positive answer. So that's why we would just have 9. But if you saw the plus minus in front, you would write plus or minus 9. Sometimes you would also see just the negative, so it's just asking you for the opposite of that square root. So it would just be asking for the negative 9. Over here, it's a little different. When I'm looking at this square root, the square root of 54 x to the 7th. So what I want to do there is see if there's any way to break this apart so that it's easier to simplify. So are there any factors of 54 that are square roots? And then when I have this x to the 7th, what do I do with the exponent there? So let's see if we can rewrite this. So first of all, I'm going to try to rewrite this. So 54 is really 9 times 6. And then if you want to think of the x to the 7th, you can break that apart into how many x squareds go in there because we're taking the square root. Or the other way that I like to think of it is you're kind of like dividing that exponent by 2 because that's the root that you're taking. You're taking the square root or the second root of this term that's underneath the radical. So you could think of that as just dividing that by 2. So you would get 7 divided by 2, which is x cubed with one, or x cubed with 1 left over. Or you could break that apart to where it's an even exponent and then an odd exponent. So x to the 6th times x to the 1st. In that case, using our properties of exponents, we'd add those together. The 6 plus 1 gives us 7. But when I simplify this in the next step, you'll see what happens, which makes that a little bit easier to simplify. So the square root of 9 is 3. The square root of 6, there's no square roots left to pull out of there, so we're just going to leave that as the square root of 6. The square root of x to the 6, like I said, you're dividing that exponent by 2. So x to the 6 divided by 2, 6 over 2 is 3. So that's x cubed. And now x to the 1 divided by 2, or 1/2, is the square root of x, right? So it's x over 1/2. Remember our properties of exponents. So that's really left with the square root of x. Or you could think of it as square root of x to the 1st still. So last thing I'm going to do is just bunch everything together. That's 3x cubed times the square root of 6x is what I'm left with. So that's the way to simplify that. Those ones are a little tricky. They're a little more involved, obviously, than just the square root of 81. But that's, again, stuff that we should know and stuff that we'll see this year. Another thing is just distribution. But when we have, higher exponents and a monomial times a trinomial, and then just remembering when we are multiplying by negatives. So you're just going to distribute this 4y, and you're going to multiply it by each term here. So 4y times 2y squared. The 4 times 2 equals 8. Y times y squared is y cubed. Plus 4 times 7 is 28. Y times y is y squared. 4y times negative 5, that's going to be negative 20y. That should be an easy one for you. Next is simplifying, where we have to do a little bit of factoring first. So x squared minus 16, I should notice that that is a difference of squares. So I know that that's going to factor as x minus 4 times x plus 4, because if I were to FOIL that out, I'd have x times x, the minus 4x and plus 4x would cancel, and then I'd have negative 16. And that's all over x minus 4. I'm thinking of that denominator as a whole quantity. So then I will cancel the x minus 4 and the x minus 4. And then I'm left with the x plus 4 as my simplified fraction. You can think of that as x plus 4 over 1. Okay, moving on. Now we're going to get into some algebra. So now we're actually going to be doing some of the solving. So I want to solve for x. The best thing to do that is by isolating the variable. So I get it by itself, which means I'm going to clear everything over to the other side of the equation. So I'll start by subtracting 10 from each side, and that leaves me with negative 3x equals negative 12. Then I'm going to divide both sides by negative 3 to isolate that variable x. And now I have the negative 3's cancel. I just have x. And negative 12 divided by negative 3, a negative over a negative is positive, so x equals 4. Moving on to another one, I have a square root. I still want to isolate that variable. So what I'm going to do here is, to cancel out the square root, is I square both sides. And remember, whatever we're doing to solve for x, we have to do it to both sides to make sure that the equation is staying the same. So I'm going to square this side and square the other side as well. So now the square root of x plus 2 quantity squared gets rid of the square root, so now I have x plus 2. Over here I have 3 squared, so 3 times 3 is 9. And now I want to solve for x, so I simply subtract 2 from each side, and I'm left with x equals 7. Do a couple more. Here's ones with square roots. Both of these, you'll notice I have square roots, but there's going to be or squares, I should say, but there's going to be a different way to approach solving each one. Over here, it's pretty easy to isolate our variable, right? I'm just going to add 49 to each side, and I'm going to be left with x squared equals 49. And so now to get just x by itself, I'm going to take the square root of both sides. So the square root of x squared and the square root of 49. In this case, I'm taking the positive and negative square root, so that I get 2 answers. I'm going to get plus and minus 7. Whenever we are solving an equation, we're basically looking for the highest exponent to see how many possible answers we can have. So the exponent that I see here is a 2, so that means I should have 2 potential answers. In this case I do, plus and minus 7. Some cases you might not, you might have just one answer, or you might have no real answers, but we'll talk more about that this year. In this case, I see a 2 as my highest exponent, so that's going to be 2 potential answers as well. If this was like x cubed or x to the 5th, then I'm looking at 3 or 5 or whatever exponents, the highest exponent is, that's how many potential answers I could have. So let's try solving this one. It's not quite the same as this approach because this is a trinomial and this one was just a binomial. It was easy to isolate the variable. But here I have x's in 2 terms, 2 different terms. So I can't just subtract this 16 over or try like dividing out an x on both sides. This one is a little more involved. What I want to do here is factor this trinomial first. So I'm going to think, what 2 binomials multiplied together give me this trinomial? So going back to our example where we had foiling, we're going to try to reverse FOIL. So I know that the x times x would give me x squared. Now I'm thinking, what factors of 16 would add together to give me negative 10? And so factors of 16, 1 and 16, 2 and 8, 4 and 4. If I multiply negative 2 and negative 8 together, negative times negative would be positive 16. Negative 2x and negative 8x would give me negative 10x. So now I have my factored trinomial, and then I'm going to use something called the zero product property, which says that if these 2 things multiply together equals 0, that means one or the other equals 0. So now I can solve for each one of these. I'm going to add 2 to each side here. So x equals 2, or x equals, adding 8 to each side, x equals positive 8. So those are my 2 answers that I get for this quadratic. And then the last thing we're going to do here is just evaluating, so being able to plug in for x. So if I have my expression 3x squared minus 10, and I want to evaluate for x equals 5, I'm going to substitute this as 3 times 5 squared minus 10. Now here's an order of operations problem. What do I do? Is it 3 times 5 and then square that and then subtract 10? Or is it 3 times 5 squared minus 10? The exponent is only attached to the x, so it's only attached to the 5. So this is 3 times 25 minus 10. So 3 times 25 is 75 minus 10, which is 65. You'd get a much different answer if you did 15 squared minus 10. So make sure you have your order of operations. Okay, so that's just a quick review. We'll do some problems in class to kind of make sure everybody is on the same page, and then we will get started from there. I hope you have a great weekend, and see you in class on Monday.